we're going to be actually solving some inequalities today and then still graphing them. So really similar to what we've been doing. We've solved a lot of equations, right? Solving inequalities is super similar. You just then kind of have to just graph them at the end. But other than that, for right now, the process is generally the same. So we're going to focus on solving inequalities that have addition and subtraction, and then we're going to focus on ones that have multiplication and division, because when you're doing multiplication and division, there's something you got to be a little bit careful of. So solving inequalities with addition and subtraction. So you solve inequalities the exact same way you would if there was an equal sign. We do the same thing. We're going to do, what kind of operations do we do when we solve equations? But like the opposite of adding is subtracting, right? And vice versa. So we do opposite operations. To get the variable by itself, exactly. Okay. Then you graph the inequality in this situation. So we could still use our two-column method here if we want. With these first few, today they're just one step, so we don't really need to do the two columns unless you want to. Okay, it's up to you. But it says solve the inequality, then graph the solution. So number one, we want to get our x all by itself. All right, we want to get x all by itself. So what opposite operation would we use in number one? Dallas? Yep, we would add 2 to both sides. Good. Add 2. Add 2. So x is greater than, and what's -9 plus 2? -7. Good. You guys can grab a calculator if you want. I need to sanitize some of them, but there's still a few left up there. And that's our answer. X is greater than -7. But are we completely done with this problem? What else do we still have to do, Jaden? We got to graph it. Okay. So when you graph it, you need to decide what kind of circle you want and then what direction to shade it. So first, let's put our circle. What number is our circle going to go on? -7. Do you think we should use an open or a closed circle? An open. Why open for this one? Yeah, very good. It doesn't have the equal to underneath that bar, right? If it has the bar, we use a closed circle. If it doesn't, we use an open circle because -7 isn't actually an answer. So it just kind of like indicates to us where we're starting. So put an open circle at -7. And then what does this symbol mean? How would we say this symbol? What does it mean? This one means greater than. When it's pointing that way, this means greater than. So what are some numbers greater than -7? Yeah, -6, but we're heading in that way, right? So we want to get, if we're looking at numbers greater than -7, don't we want our numbers to get bigger? And if we want our numbers to get bigger, should we shade to the left or to the right? To the right. Good. Yeah, so we're going to shade to the right. And how you want to shade is kind of up to you. I'm just going to use my highlighting tool and highlight it. If you want to like scribble it in or whatever you want to do, that's up to you. But I need to see your circle and I need to see what direction your arrow is going. So let's take a look then. We're going to come back to 2. I'm going to have you do 2 in a second. Let's take a look at number 3. We have 5 plus k is greater than or equal to -3. We want to get our k all by itself. So what opposite operation should we use here to get rid of the 5? Yeah, we're going to subtract 5. Good, because it's a +5. It's being added. So we're going to subtract it. Your 5s will cancel out on the left, and you'll have k is greater than or equal to -3 minus 5. What would -3 minus 5 give you? -8. Good, Dallas. -8. Good. What do we think on this one? Open or closed circle? Closed. Closed at what number? -8. So put a closed circle at -8. And how do you read this symbol? Is this a greater than or equal to or a less than or equal to? It's a greater than or equals to. So do we want our numbers to get bigger or smaller? Bigger. So should we shade to the left or to the right? To the right. So we shade that way. I decided to do a squiggle this time. You writing this down, Jaden? Okay. All right. So I want you guys then to try out number 2 and number 3. M minus 3 is less than or equal to 5. Lynn, what opposite operation would we use to solve number 2? Yep, we are going to add 3. Add 3 to both sides. Your 3's on the left cancel. M is less than or equal to, what'd you get, Lynn? 8, good. Good. Jaden, do you think this should have an open or a closed circle at 8? Closed circle at 8, good. And then this is a less than or equal to sign. So we want numbers that are going lower, right? So Corey, would we shade to the left or to the right? Yeah, shade to the left. Good. Questions on that one? Do you got that? Yeah, okay. All right, number 4, x plus 4 is less than 2. Asia, what opposite operation would we use here? Yep, subtract 4 from either side. X is less than what, Asia? -2, good. Mason Jimenez, do you think open or closed circle at -2? Well, for this one, it doesn't have the bar underneath it. So when it doesn't have the little line underneath it, which one do we use? Open, yeah. Open circle at -2 for this one. And then this is a less than. So Dallas, should I shade to the left or to the right? To the left, good. Okay. Questions on those? Do we have that down? Did we fix it if we did something wrong? Okay. People at home, any questions yet? All right. So number 5, we have -7 plus m is greater than -11. We want to get rid of this -7, right? We're adding a -7. Remember from something, I think we talked about this like one of the first days of school. When you have a addition and a subtraction, which one's more important? The subtraction. So that's the one you want to focus on here, that negative, right? Because if you move a negative over, what's it going to become? A positive. So with this one, it's very tempting to subtract 7 because you see this plus. But if you subtract 7 from -7, is that going to cancel out? No. We need to add 7 to both sides on number 5. We need to add 7. The 7s will cancel, and you'll have m is greater than, what's -11 plus 7? -4, good. So m is greater than -4. So if it's just greater than, Bailey, do you think we'd use an open or a closed circle at -4? Yeah, very good. Open because there's no line under it. And we're looking for numbers greater than -4. So Aaron, do you think I would shade to the left or to the right? To the right, good. Okay, good. And you will have to know like which direction means which, okay? So just make sure you have that in your head. All right, number 6. We have 13 plus x is greater than or equal to -4. I want to get rid of that 13. Annalise, how could I get rid of that 13? Very good. Subtract 13 from both sides. You get x is greater than or equal to 4 minus 13 would give us -9. Good. Make sure we're not just letting Dallas and Asia do all our adding and subtracting for us. All right. So now we need to do our graph. Hannah, do you think you'd use an open or a closed circle at -9? Closed, good. Because we have the bar underneath it, right? When it's the or equal to, use a closed one. And now this is a greater than or equal to symbol. So if it's a greater than or equal to, also look at what direction your arrow is pointing, right? So, Kaysen, do you think we should shade to the left or to the right side? Any idea, Kaysen? Not sure. Okay, what about Jesse? What do you think? Where should I shade, Jesse? To the right. Good. Because we're looking for numbers that are greater than -9. So we want to move where our numbers are getting bigger. All right. Do we have any more adding and subtracting? I think maybe 2 more or so. I called on Kaysen. Yeah. No, that's okay. Kaysen, Mason kind of sounds the same or similar through Google, I'm sure. All right. Oh, I guess we are done with those. We only had 6. Perfect. How do we feel about the addition and subtraction ones? Better? Good. All right. Now let's talk multiplication and division. This one has a little bit, just a touch of a trick to it, something we have to look for and pay attention to. So we're on the back page of our notes now. Okay. So solving inequalities using multiplication and division. Same process is going to happen. Solve inequalities the exact same way you would if there was an equal sign. Okay, so same process. Do your opposite operations. So do the opposite operation to get the variable by itself. Then we're still going to graph our inequality. Okay. So these ones I lied. These ones are actually still basic. It's when we look at the next little set that there's a little trick to it. So we're going to do the exact same thing, but let's refresh our memories. What's the opposite of multiplication? Division. What's the opposite of division? Multiplication. Okay, so if you see division, do multiplication. If you see multiplication, do division, do your opposite operations. So in number 1, we have 2x is greater than 6. So remember, we're trying to get our variable all by itself. So we want to get x all by itself. But what's stuck to that x? Times 2. So Dallas, how would we get rid of multiplying by 2? Very good. We would divide by 2 on both sides. Good. The 2's on the left would cancel. And you'd have x is greater than, and then what's 6 divided by 3? I'm sorry, what's 6 divided by 2? 3. I do that a lot. I'll like say the answer instead of asking you guys the question. I do it all the time. Okay, so we have x is greater than 3. So, Corey, open or close circle at 3? Open. Good. Okay, now let's practice recognizing what our symbol is. How do I read this symbol? What does this one mean? I've already said it, but do we remember? This is a greater than. So if it's a greater than, Bailey, do you think you would shade to the left or to the right? To the right, absolutely. Good. Good. My arrow doesn't really look like an arrow, but we'll pretend. Does the trick. Okay, so let's look at number 3, then I'm going to have you guys try 2 and 4. So number 3, we have W divided by 4 is less than -2. So we want to get our W all by itself. We're currently dividing it by 4. Mason J, what would be the opposite of dividing by 4? Multiplying by 4, exactly. So we're going to multiply both sides by 4. Our 4's on the left are going to cancel. Are you writing this down? And we have W is less than, and -2 times 4 is -8. Good. Okay. So now we need to graph this. Mason B, open or close circle at -8. Open, good. And then what does this symbol mean, ladies and gentlemen, when it points to the left like that? It means less than, good. So Nick, if it's less than, should we shade to the left or to the right? To the left, good. Good. And I'd like you guys to try out 2 and 4. 2, we have 3y is less than 9. 3y is less than 9. We want to get y all by itself. So, Kaysen, what opposite operation would I do to get rid of the 3? Yeah, we would divide. Good. And then we would get y is less than what, Kaysen? What's 9 divided by 3? 3. Good. So we now have y is less than 3. Aaron, open or close circle at 3? Open. Good. And Annalise, what direction should I shade? To the left. Good. All right, last one of these. Number 4, we have n divided by 3 is greater than or equal to -3. Hannah, what opposite operation would I do here? It is more than, it is greater than. What would I do to get rid of dividing by 3 though? Yeah, we would multiply, good. Multiply both sides by 3, and Hannah, we would get n is greater than or equal to what? What kind of a 9? Get -9. Good. Lynn, open or close circle at -9? Closed, good. And Jaden, shade to the left or to the right? To the right, good. Okay. We feel okay about those guys? Any questions yet? Hopefully not too bad. All right. Are we really sleepy today? I feel like we're kind of quiet and out of it. Are we quiet and out of it? Yeah. Well, it's early. I know I'm tired. Yeah. All right. Well, good. All right, what if you have to multiply or divide both sides by a negative number? Now, here's our little trick that happens with these, a little place where we got to be a little bit more careful. When you multiply or divide both sides of an inequality by a negative number, you're going to have to flip your sign around. Okay, it makes it go the opposite direction. So when multiplying or dividing both sides of an inequality by a negative, I keep trying to write in highlighter. So by a negative, you need to flip the inequality symbol. So a greater than is going to become a less than. A greater than or equal to is going to become a less than or equal to, right? And vice versa. So let's take a look at number 1. Solve the inequality, graph the solution. Remember, only flip the sign if you multiply or divide both sides by a negative number. Okay, so that means if your opposite operation involves multiplying or dividing by a negative number. So look at number 1. We have -3 is greater than 9. What would I do? What opposite operation would I do to get rid of the -3? We would divide by -3. Good. So my -3's are going to cancel, and I'm going to have x's. Now, is this a situation where I'm dividing both sides by a negative? Absolutely. So if I divide both sides by a negative, my greater than is going to switch to a less than. And 9 divided by -3, a positive divided by a negative is a negative. And 9 divided by 3 is, yeah, 3. So it'd be x is less than -3. You get used to it. It becomes very, you flip it because it changes the value, like it changes whether the left or right side is positive or negative. So it reverses your whole graph. Okay. So with this one now, we want an open or a closed circle at -3. Open, and be careful with your -3. You don't quite see it on here. It'd be between -2 and -4. So put an open circle there. And now this became a less than. So what direction would we shade? To the left. Good. Good. All right, let's try that again. We writing this down over there, guys? Okay. Number 2, we have -2x is less than 10. So what opposite operation would I do to get rid of the -2 next to my x? Very good. We would divide. Divide both sides by -2. So in this situation, do I need to flip my inequality? Are we dividing both sides by a negative? Yes. Flip your inequality, turn your less than into a greater than. And then what's 10 divided by -2? -5. Good. Good. And now we are going to graph this. So we need Jake Sanders, open or close circle at -5. It is going to be open. Yeah, open circle at -5. And then with this one, we would shade to the what? To the right. Good. Okay. All right. So now let's take a look at number 3. We have m divided by -2 is less than or equal to -3. What opposite operation do I need to do to get rid of dividing by -2? Multiply by -2. Good. My -2's will cancel out on the left, and I'll have m is, Corey, do I need to flip my inequality symbol? Yes, I do. I need to make this a greater than or equal to. And then be careful here. What's a negative times a negative? A positive. Good. And then 3 times 2 is 6. So it'll become m is greater than or equal to 6. So Alex, open or close circle at 6? For number 3 here, the one we're just doing now, since it's a greater than or equal to, should we use an open or a closed circle? Remember from yesterday, if we have the bar underneath, closed, good. Sound familiar now? Okay, that's okay. I don't expect you guys to get everything right all the time. All right, and this is greater than or equal to, so do I shade to the left or to the right? To the right. It switches directions because when you multiply or divide both sides by a negative, it changes the value on either side. So the whole thing, right, the whole thing has to switch. All right, let's look at number 4. We want to be careful on number 4. We have 3m is greater than or equal to negative 24. What opposite operation would I use? Division. What are we dividing by, Asia? And number 4. It's okay. By 3. So I'm dividing by 3. Aren't I dividing by a positive 3? If I'm dividing by a positive 3, do I need to flip my inequality symbol? No, but wait, but Mrs. Geyer, the 24 is negative. So, yeah, very, very good. It's not on the correct side, right? In order for you to flip it, you have to, it's when you do your opposite operation, right? So here, since we divided both sides by positive 3, you don't have to flip it. We're just going to leave this as m is greater than or equal to negative 8. Good. Nick Lopez, open or close circle at negative 8? Closed, good. And Mason B, shade to the left or to the right? To the right, good. All right, I think we're almost done. Is this the last 2? Yeah, last 2. All right, last 2, try these ones out, guys. Try out 5 and 6, and then go over this. We have negative 9x is less than negative 27. Hannah, what opposite operation am I going to do for number 5? It is a less than. What should I do to get rid of the negative 9, though? Like, do I want to multiply, divide? For number 5? It doesn't say 9 minus x, right? Isn't this negative 9 times x? No, that's okay. So how do you get rid of multiplying by negative 9? Division, yeah, good. So divide by negative 9. Good. Ladies and gentlemen, is this a situation where I'm going to have to flip my inequality symbol? Yes, why? Very good. Yes, you are dividing both sides by a negative number, and because Jaden observed there's a negative on the left, right? Chances are then you're going to have to flip it. Good, so that's going to become x is greater than, and then what's a negative divided by a negative? A positive, and what's 27 divided by 9? Positive 3, good. Mason Jimenez, at the 3, do we want an open or a closed circle? Open, good. And Corey, what direction should I shade? To the left or to the right? To the right, good. And then last one, number 6. We have w divided by 10 is greater than or equal to negative 2. Bailey, how do you get rid of dividing by 10? What would our opposite operation be? Yeah, multiplication by 10, good. So we'll have w. Do I have to flip this one? Is this going to be one that I have to flip? This one is a no. The 2 is negative, right? But I didn't divide or multiply both sides by -2. I multiplied both sides by +10. So if it's positive, do I need to flip it? Nope. Leave it as a greater than or equal to. -2 times 10 is -20. Good. And now let's graph it. Annalise, open or close circle at -20? Very good. It is a closed circle. And then Jake Sanders, should I shade to the left or to the right? To the right. Good. Excellent.